And we have my favorite student. Okay. 2 marks, units of a force, newtons. Hopefully you all got that. I'll do that first. What's the definition of a force? If you said a force is a push or a pull, because that's, I think, what I said at the very, very beginning of lesson 1, I'd give you that. If you cleverly said it's a mass times an acceleration, my little math nerd heart would go pitter-pat, and I would say, yes, it is. If you said it's the interaction between two objects when they exchange bosons, I would say someone's been reading Wikipedia or looked at a quantum, and I would take that. Anybody say anything else? Or if you said that which causes an object to accelerate, I would say, yeah, that's what forces do. Any other definitions out there? I suspect most of you said push or pull, and probably a few of you might have gone F equals ma. Okay. What force? Net force? Okay, as soon as it says net force, I can go straight to F equals ma, and they want me to find the net force. It's going to be 1,200 times 2. Heck, I can even do that in my head. 2,400 newtons, yes? 1 mark. Number 3, 3 marks suggests this is multi-step. It did say find the net force, so I went F equals ma, and then I read the question and I said, did they give me m? Yes. Did they give me a? No. So even though this says find the net force, you know what I'm going to spend most of my time finding? I think the acceleration. So I drew the line like this and I said, okay, a equals question mark. I saw a distance of 1.5 meters long, a displacement. I saw a VF of 770. It told me it starts at rest. I'm going to argue I probably don't need to tell you that a bullet or an artillery shell or a cannon starts at rest, because I don't think I've ever seen one where they don't start at rest. But anyways, I did do that. I'm going to use what? A equals VF squared minus VI squared all over 2D, I think. It's going to be 0 squared minus 770 squared all over 2 times, I got that totally backwards, Mr. Dewick, 770 squared minus 0 squared. I caught that before someone got a candy. All over that. I have no idea what the answer is. Bracket 770 squared minus 0 squared. Did I really need to type the minus 0 squared? Will that change anything? Nah. I didn't really need to. Brackets around the bottom, though. Or I could have gone 2 times 1.5 is 3 in my head and saved myself some typing. Holy... That's... Wait a minute. Is this an artillery shell? Is that going from 0 to really fast in a short distance? Would that require a fairly big acceleration? I'm okay with that. At first I was nervous, but then I went, wait a minute. That's probably what it would be. So I'm going to write 198,000, but I'm going to store this on my calculator. So 198,000. But now I'm going to walk over here. So F equals 65 times my answer button, 197, whatever it was there. Do you get a big number? I'm going to write, now if you wrote it out, that's fine. I think I'm going to go to scientific notation. 1, 2, 3, 4, 5, 6, 7. I'm going to write 1.28 times 10 to the 7th. Newtons. By the way, forces come in. So when that hits another object, that's the force it will deliver. From what you know of war, are artillery shells pretty devastating? So that answer doesn't creep me out that, oh yeah, it should be a massive force because they do a lot of damage. I'm okay with that. Is that right? Is it 1.28 times 10 to the 7th? Or 1 million, whatever. That? Okay. 3 marks if you got that. Otherwise, I would probably do something like this. I would give you a half mark if I saw F equals ma. I would give you probably a half mark if I saw that you had realized to find a. Half mark for that. Half mark for finding a. And then a half mark for going 65 times your answer. So if you got the wrong acceleration, but you went the wrong acceleration times 65, I would give you 1.5 out of 3. I'd give you at least half marks. A net force. A what force? A net force. It looks like it wants me to find A. I'm going to use Shay's theorem. So it's going to be 12 divided by 1.2. I can do that in my head. It's 10, yes? Meters per second squared. Number 5, average acceleration. I said, okay, I see a t equals 32. I see from rest. I see a v final of 3.2 times 10 to the fourth. You know what? I'm going to find acceleration using kinematics from before Christmas. 3.2 times 10 to the fourth minus 0 all over 32. I can do that in my head. Certainly I can do the minus 0 in my head. And it's going to be 3.2 divided by 32. Is it 1,000? Even, right? Right around 100 Gs. This spaceship would not have people on it. What's the average net force? What force? Net force. Oh, F equals ma. What was the mass of the spaceship? 4.5 times 10 to the fourth times 1,000. That's just going to be 4.5 times 10 to the seventh newtons, I think. Yes? Or a 4, a 5, and then, yes, 6 zeros would be after the 5. A net force. A what force? A net force. Okay, but A is worth 2 marks. I guess that suggests maybe it requires more than one step. How far? D equals question mark. Well, they gave me a VI of 0, a VF of 12. What else would I need if I wanted to find the displacement? Oh, an A, you say. I can find that using Shay's theorem. The force is 1.6. The mass is 6.4. I think that's 0.25, yes? So now I can plug that in here. And so D is going to be VF squared minus VI squared all over 2A. It's going to be 12 squared minus 0 squared all over 2 times 0.25. I can do that in my head too, because it's going to be 144 divided by 2, which is 72, but dividing by 0.25 is the same as timesing by 4, so it's going to be 72 times 4, 288? Meters. If you got that 2 out of 2, otherwise I would probably go half mark for that, half mark for finding A, half mark if I saw that, and a half mark for the answer. How much time did it take the object to travel the distance in A? No matter what, I'm going to use an answer to find an answer here. So I wimped out and I went with T equals VF minus VI over A, because that was the easiest way that I could think of to find time. You could also use D equals VIT plus a half AT squared. You could also use D equals bracket VI plus VF close bracket times T over 2. The only one you couldn't use is the one that doesn't have time in it. VF squared equals VI squared plus 2AD. I went with this one. So it's going to be VF 12 minus 0 over 0.25, 48 seconds, yes? Really, that should have been worth 1 mark. I think I was copying and pasting and just pasted the 2 marks down. So for 2 marks, I guess it'll be 1 mark for the equation, half mark for the numbers, and a half mark for the answer. But it was a 1 step. And you've all turned the page. A book is sitting on a level desk. Which of the there are no forces acting on the book because it's not accelerating. No, definitely gravity is acting on it. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. Is it sinking into the ground like quicksand? Is it flying like Superman? Then I think that's true. That'll change today because I'm going to add extra vertical forces to the diagrams. And that's the only time that would not be true, is if there was extra vertical forces. What if somebody was pushing down with their hand on the book? That would change how hard the ground had to push back up. The net force on the book is equal to 0. Is the book accelerating? Then that is true. Friction, Is friction what's holding the book on the desk? Could your desk be made of ice, and could the book still sit on it? As long as the desk was level, which it is. So I don't think friction is what's holding the book on the desk. So fatitifif. Half mark for each of those. I like number 8. I like number 8. Mr. Dewick, it's already on the quiz. Oh. So if I say it and it's on the quiz already, what do you think I'll let you figure out what you think I'm saying, Hannah. But I bet you can put it together and figure out what I just hinted at. Elevator accelerates up. I'm going to do a free body diagram, get the obvious one. We're accelerating up, normal force is winning. My equation is going to be normal force minus mg equals ma. What's this question asking me to find? The scale reading. What's it really asking me to find whenever I'm talking about a scale reading? Normal force. As far as I'm concerned, I can give you the acceleration and say find the normal force if you're in an elevator, or I can give you the scale reading, normal force, and ask you to get the A by itself. I think the only thing I wouldn't bother, well, I guess technically, Jordan, I could put you on a mystery planet, give you the normal force, give you A, and ask you to find the acceleration due to gravity on the mystery planet, get the G by itself. I've never done that, and I'm not going to do it this year, but once we're back to normal, I've just decided, ooh, that's a neat question. That'll go on a test, because I can travel to outer space to a mystery planet. Anyways, how would I get the Fn by itself? I would plus the mg over, which is going to be either ma plus mg or mg plus ma. Do I need to multiply the 588 times 9.8? What are the units next to that 588? That's already mg. Look, I didn't say they had a mass. I said their weight. That's already mg. I don't need to multiply that by 9.8. If you did, you're going to lose a half mark. Plus, do I know m? What's the mass? Not 588. Please, if the person's mass is 588 kilograms, this elevator is not going up. Sorry? How'd you figure that out? Did you? So you went over here somewhere, m is going to be 588 divided by 9.8. $60? So it's going to be 60 times 1.2. I should be able to do that in my head before I hit equals. 60 times 1.2 is going to be 60, plus 12 is going to be 72. It's going to be 588 plus 72. 660? Yeah? What if instead, I'll talk about part marks in a second, but what if instead I had asked you to tell me what the scale was reading in kilograms? In other words, what if it was a scale that didn't read in newtons? What if it was a scale that read in kilograms? How can I convert a newton to what a scale would say in kilograms? Divided by 9.8. This person, the scale, if it was a kilogram scale, would be saying that they had a mass, of 67.3 kilograms. They would feel heavier. Now, if you did not clue in that this was newtons, if you use the m as 588, you would go 588 times 9.8 plus 588 times 1.2. I would give you 1.5 if you said 6,468. But please understand, you've just said that the person on the scale would display 660 kilograms, which is a little bit much. Elevator accelerates downwards. I could redo the free body diagram, but let's see if I can just modify the one that I did here. If we're accelerating downwards, who's winning? Yeah, I think my equation is going to be gravity minus the normal force equals ma. How am I going to get the ma by itself? Swappy dance. And I'll get mg minus ma, and I'm going to put the normal force by itself on this side. So it's going to be 588, or 60 times 9.8, minus 60 times 2.25. You get 453? Again, if you use the mass as 588, I would give you 1.5 out of 2. Okay. Elevator moves up at a constant velocity. At a what? You know what? Normal force equals mg. Doesn't equal 0. They don't feel weightless at a constant velocity. It's just going to be 588 newtons, 2 marks. When would they feel 0? When would they feel weightless? If they're in free fall, like in D. If we're accelerating down at 9.8, you'd have a normal force of 0 newtons. 0. Okay. So each of these is worth 2 marks. Basically, I would probably give you something like this. Half mark for that, half mark for getting the Fn by itself, half mark for the numbers, and a half mark for the answer. And so if you put the wrong numbers in because you thought m was 588, in theory you would still get the 1.5. Can you give yourself a lovely score, please, out of 23?